Okay, so this is, I think, the last in my series. I may be doing some additional videos based on some other topics, but this is one of the other documents that I put together. This one is about SQL tools for big data analysis. Some of these are SQL tools, some of these are others. Some of them you'll probably be familiar with, especially if you've had done some type of data analytics or you're a data analyst or some of those kind of things. I'm also going to talk about some other different topics related to that, like bringing up things regarding NoSQL and that kind of thing. But let's get started. So, one of the things you have to think about in order to do data analysis, you kind of need a database. I mean, it's kind of obvious, but yes, you need a database. And in the world of MySQL, there are different types of databases. Because remember, we want to do big data. Remember, you've heard some of my other conversations where I talked about vertical versus horizontal scaling and all of those kind of different things. Here we're looking at horizontal scaling because we want to be able to make a really large database. So one of the options we have is a tool called MySQL Cluster, which allows us to have high availability and performance because it is a horizontally scaled version of MySQL. We have the enterprise edition of MySQL. So MySQL is free, but MySQL is owned by Oracle, and there's a non-free version. And there's some additional goodies that you get if you decide to pay extra money. And many of those are things related to scalability, performance, and security. You can use MySQL with Hadoop. Oh, Apache Scoop. I used to love Scoop. Unfortunately, Scoop's not really maintained anymore, but it still exists and it still works. I worked on an application where we were migrating data from MySQL to Hadoop. So, like, we had a database with 2 months worth of data, and we wanted to load it into our 2 years of data Hadoop cluster. We used Scoop to be able to query tables and put that data into MySQL. The other thing you can do is we also use the Apache Hive. Hive allows you to be able to treat CSV files as though they are tables and query them with a SQL-like language running in Hadoop's HDFS. Far more technical than you probably care about, but I used to maintain systems like this. I've done it multiple times. And then MariaDB. So when Oracle bought MySQL, the people who had MySQL decided to create MariaDB, which is basically a fork of MySQL. They have their own toys that they built too that allow you to be able to do big data databases. This is more for someone like me as opposed to someone like you. I mean, most business people don't really care. They just want to be able to query their data and do their thing, but you should be aware of it because maybe you get involved in that conversation. They're trying to figure out what they want to do, and you can give them advice based on some of the information here. How do we query the data? We have lots of tools. One of the things we will have you do in this class is install MySQL Workbench. Matter of fact, I'll just show you a quick little peek of it right now. Where is it? It's open. Oh, there it is, MySQL Workbench. I'll show it to you for a second. I'll connect to my MySQL database. Yeah, I know. They need to update this version, but it gives me a place where I can write my own queries. As you can see here in my different databases, and I could say, okay, let's run this query, and I can uncomment these out, and I can run a quick query and say, ta-da! Okay, this is how many shipments I have. So you will be using this tool to help you with some of the queries that you would develop as we go on in this class. But that is definitely a tool that I like, partly because it's a visual tool. I mean, if I'm writing code, maybe I want to test it visually before I actually put it in my application. It's easy to just bring up MySQL Workbench and just run a query. Well, for people who do analytics, there's Tableau. Tableau is kind of one of the real popular visual analytics platforms. Now you have Power BI from Microsoft that's really starting to make a lot of inroads and things like that. I'd never heard of this thing called Looker, but when I was looking up different analytics tools, it was one that popped up. Maybe some of you have some familiarity with it. Grafana is something I've used a lot. Matter of fact, many of the apps that I've built at work at Adobe, we use Grafana. Grafana is free. It's really simple for me to write a query and then say, okay, create a bar graph, create this, and then all of it is accessible via a browser. And we use it quite extensively on some of the projects that I do. I do a lot of analytics type work, but it's different type of analytics work. The analytics work I do, it has more to do with how servers perform, how databases perform, and that type of analysts. And I mean, it's that type of analysis. So I use tools like that to be able to show things in a graphical format. So We have lots of databases that could be classified for analytics, and the most popular type of database used for big data are what are called NoSQL databases, which stands for not only SQL. Some people refer to it as not only SQL because some of them do allow SQL, like Cassandra, and then some of them call them non-SQL because they have their own way of doing things. And there are different categories of NoSQL databases. There are document-based ones, which would be like MongoDB, which stores data in semi-structured data like JSON, XML, or YAML. You have key value, which means you have a unique key, 1 = Craig, 2 = Joe, 3 = Jane, simple key value. You have graph databases, which are fascinating to me. I've been starting to spend some time researching those, and I've used them in a few different personal projects that I'm doing at home. But the concept is a graph database. Each row is a node, and each relationship is called an edge. And what's nice is the relationships are already stored. So as opposed to having to join, let's say, person to address, that relationship's already established. I just go and grab the data. Very cool stuff. Um, then you have column-oriented databases or columnar databases. Those are very similar to relational databases, but the storage paradigm is different. So instead of storing the data in terms of rows, you store the data in columns, which obviously means that tables are more narrow, meaning that they are smaller, meaning they'll be more performant. Then you have data warehouses, which I'm going to probably do a video for of a data warehouse I built for a presentation I gave for the data science club for the CS department. But typically in a data warehouse, it's usually an aggregation of a lot of data, maybe 7 years, 10 years, whatever. And what you do is you have what are called facts. So facts might be number of sales. Facts may be customers. Facts may be other pertinent information. And then what you're doing is that you're using it and you're mapping it by dimensions. As an example, how many sales have we had on every Wednesday for the last 7 years? Why are Wednesdays we're not selling products, but we're selling lots of products on Friday? That kind of thing. Why do we sell more? And then let's say I have every month. So basically, I'm going to have every January for 7 to 10 years and look at the values aggregated for that. Why do we sell better in August than we do in March? That type of thing, or quarter or year. But you get the point. The other type of database is time series databases. I would like to play around with these, but typically this is for timestamp data. So think of this about like data that is streamed. Let's say you have a website that's streaming data as people are doing it. You want to store it in a time series because what really matters is the timestamp of the data and keeping that data in order. Um, I have not really had a chance to play too much with any of these. They're on my to-do list of things to play with. One of the things I love about what I do for a living and why I've been doing it so long, people ask me why, is because I get to play with toys for a living. I'm like a 12-year-old. Every time they have a new toy come out, or an 8-year-old, I'm like, ooh, that's cool. So this is something. Why would I pick one database over another? That's one of the things I cover in my CS 3530 class. My students actually build these databases out. They actually do real world queries and real world things. And then we kind of talk about, well, why would you pick one over the other? Well, why would we want to pick a document database? One is if we have semi-structured data, it's a great place for that. And it also allows us to be able to search that data like we would almost a relational database, but we're searching semi-structured data like JSON or XML as opposed to searching rows and columns. But ultimately, it allows us some of that same flexibility for data that is not in a, like I said, tabular format. Key values are really nice for simple things. 1A, 2B, 3C. You can have millions and millions and millions of rows. They're really good for that. There's a database called Redis that's actually in memory. One of the applications that we built, we actually put all of our keys, all of our like unique codes. 1 = this, 2 = this. We had all of those in a key value database in Redis, and our website could read that instead of actually having to go to the actual relational database. And because that database was in memory, everything was lightning fast. Why would we use a column-oriented database? Well, ultimately, if we have rows and data, why not store it instead of storing the data in rows, we'll store it in columns. And it uses less memory because of the width of the tables. And that way we can have more data to fit in memory. So that would mean that our queries will be much faster. So that's one reason, like the database like Cassandra is used for that. Snowflake is also a columnar-based database. Um, You can have graph databases, which are really nice for, um, what do you call it? Are really good when the relationships are there. And the other thing that's really cool about graph databases is you remember how when we dealt with relational databases, everything was supposed to be a one-to-many. We don't allow many-to-many relationships. We have to normalize everything. Graph databases were specifically built for many-to-many relationships. Because if you look at like the example they always give, like a social network, I'm friends with this person and this person I'm friends with because I bike. I'm friends with this person because of this. And all the different types of relationships you could have, there's going to be a lot of many relationships. And you can build all of that into a graph database. Why would I use a data warehouse? Well, data warehouses are typically better for aggregation. Like I said, I don't want to query 7 years of raw data. I want that data aggregated. Like I said, how many widgets did we sell on Mondays? And it allows businesses to make strategic decisions with that because the powers that be, let's say sales managers or head of sales or, chief, what do they call it? Chief sales officer, whatever they call those, be equity, whatever they call them. Anyway, my point is that it gives them a concise database for them to be able to look at trends and try to figure out what they need to do from there. And like I said, time series databases are really good if you're just looking at streaming data that has a timestamp. So let me name some that different types of databases. You have MongoDB and Cosmos DB. I've worked with both of those. Cosmos DB is an Azure-based database. Interesting. Has some cool things to it. Mongo I've used quite a bit as well. I've used Redis. Memcached, I've never used that. Neo4j is one of the things I teach. Amazon NetToom, I've never used that one either. Um, Columnar-based databases, Cassandra and Snowflake. Data warehouses like Hive and Redshift. Redshift's a cool product. I used to work on that. That's an Amazon product. I used to support that. And this should not be graph databases. This should say time series databases. I love fixing stuff on the fly. Yes, and this open TSDB, one of the teams that I work with at Adobe uses this for something. I don't know what they're using it for, but I know they use it. And this is also another very popular time series based database. So we kept talking about structured, semi-structured, and unstructured. Let's talk about them. Structured data is pretty straightforward. Spreadsheet, CSV file, tabular data, stuff we've been working with since the beginning of time, been around forever. Semi-structured data, JSON and XML, these are different file formats that data is stored in. It does follow a pattern, but it is semi-structured. It's not completely structured. And then unstructured data, which we talked about a little bit before, images, audio, freeform text, emails, things like that. It's just much harder to work with, much harder to do things with. Can NoSQL databases can store? Yes, columnar databases can store like an RDMS. I talked about that a little bit. Document databases can store semi-structured data. Matter of fact, Mongo does that. Relational databases can also do key value. I read an interesting white paper where somebody basically created a table with a key and a value. So one column, two columns, one a primary key and one like that, like we would a code table. And he compared it to many of the key value databases and found that they are pretty performant. There's not just NoSQL that can be fast. And then unstructured data, I don't know. I would prefer to keep it on operating system and not even bother with databases because, like I said, they tend to be large. They monopolize all your cache. They use up, which means they use up all your memory. So queries can't run properly. They all have to read data from disk, which makes them painfully slow. I would leave them on the file system and let them deal with it. So, non-transactional structured systems. This is an interesting topic. This is something I had never really spent a lot of time dealing with, but it was kind of fascinating to kind of read about it. And what it is that think of this as a lot of our NoSQL databases, where we're basically saying, you know what, we don't care about transactions. Remember we talked about base, we're much more lax about things. That's what these non-transactional things are. We don't have to incur the overhead of ACID. We don't have to deal with typically they are downstream. Like I said, you have an operational database. Like I said, we have a database we use to sell widgets. Then we might have an analytics database that certain analysts use to see how well we're doing over the last 6 months of selling widgets. Um, Really popular with big data applications because, I mean, you're not really, this is something that I've had to build in the systems as well, is when you're dealing with operational databases, you want to keep those tables small because if you have to read anything, if you have to write anything, you want to make everything really small. Operational databases will not be big data. So back in the day, we would have a history database. So an example, instead of using what we do now with analytics, I'd have two relational databases. One would be the day-to-day database of how we have X amount of days worth of data, usually no more than a handful of days. And then we'd have this history database that would have a year's worth of history or 6 months worth of history or whatever. I mean, obviously those things were slow, but we never mixed the two together because they don't play well together. They're like oil and vinegar. So the real power of non-structured systems is really, like I say here, to facilitate analytical exploration. What can our data tell us? What can our data teach us? What does our data say about our company and us as an organization? That is the power of those types of databases. Oh, examples. I gave some examples of my own. You can use Cassandra. Cassandra is an interesting database. It's terrible as an operations database. It's awful as an operations database. And it's funny how Cassandra came about. At one point, Facebook had the largest MySQL database in the world, and all of us database people were waiting for it to crash. Well, before it crashed, they created a database called Cassandra and started migrating things from MySQL to Cassandra. Cassandra is an excellent database for analytics. It is not a database you want to be doing transactions on because it is terrible for that. As a matter of fact, that's one of the things I teach in my 3530 class about how terrible it is at that type of work. Um, Data warehouses, a lot of that is aggregation we're doing. So maybe we have a process every night that grabs all of our sales and aggregates it and adds it to. So let's say if today is Sunday, which it is for me, making these videos, then what did we sell on Sunday? And we add that to whatever Sunday. It's still the month of February, so we add it to February. It's still the first quarter, we add it to the quarter. It's still 2025, so we add it to 2025. You get the point. Um, One of the things that we played around with is real-time web traffic. A lot of times is in JSON. We might want to put that data in MongoDB, but we could also put that data into a time series database as well, depending on how the data looks. I chose to say Mongo here because of the JSON format, but depending on what type of data that you're capturing, because let's say if that data has timestamps on it, you might want to use a time series database. Oh, so here's what happened. The NoSQL databases got their marketing and said, hey, we're the only ones who can scale. We're the only ones that can do this. We're the only ones that could do that. And it's true for a while. But then the relational database people got together and said, you know what? Why can't we do this too? And that was the birth of NoSQL. So what it does is it allows you to keep all the things you love, like ACID and integrity and all of that good stuff. But now you can horizontally scale just like the new SQL databases, meaning you can have multiple commodity servers, or if you're in the cloud, you can have multiple virtual machines that are small and you can swing. I love building stuff in the cloud. You can make it big, you can make it small, you can call it grow, and it's all done programmatically, which is amazing stuff. I love writing code like that. But anyway, New SQL kind of changed the whole way that we viewed things because it gave us everything that we loved, SQL language. It gave us ACID. It gave us all the things that we've come to know and love about the integrity of our data. But now we can scale too. So that vertical problem that we were facing, we no longer face anymore. So it's changed the way things go now. So if you look at what is new SQL, remember, it maintains the same RDMS principles that we know and love. It works with transactions just like we're used to in ACID. But guess what? It's also horizontally scalable. So we don't have to have that problem with a vertical database being too small, which also means that we can now support very large amounts of data and very high volumes of data because now we can scale. And you remember how we talked about how each individual node of a horizontally scaled environment can work independently, distributed processing? Guess what? We get that too, and then eliminated the need for middleware. So one of the things we used to do in the old days, it's so funny how many things we used to have to do, but you would build a middleware. So let's say, dumb example, let's say I have an application that's for the state of Nevada, Utah, Colorado, and Mountain West. So I have the separate states for that. I might build a system with middleware that says when data comes in, it determines the state. And I've got four separate databases. It says, oh, you're Utah, you go here. You're Nevada, you go there. Oh, you're Colorado, you go there. You're New Mexico, you go there. That type of thing. Well, you don't have to do that anymore because all of that is built in into the way NewSQL databases are built. And one of the things, so this is looking at the advantages, disadvantages. I probably should leave the NewSQL part out. I kind of wanted to, but nah. Why use an NoSQL database? So we've talked about that. Sometimes I feel like these documents are a little disjointed, but whatever. We'll talk about it. Flexible schema. One of the things I love about Mongo is Mongo, you could have a JSON file and you could add a whole much more to it. And Mongo's like, all right, cool. I'll load it. That's what you want. That's what I'll do. We can't do that in a structured data. We must know the columns up front. The other thing that people like is developer familiarity. This may not mean things to you, but when I talk to my resident developers, there's a difference. SQL is a separate language as opposed to like Mongo, which has a query language that's very similar to writing object-oriented code. So there's that. Lower manageable costs. I always, sometimes I wonder why people say these things, but I guess the lower manageable cost is because we can buy commodity servers. Accelerated development, yeah, whatever. Anyway, sometimes I wonder why people say these things. I think the accelerated development is only because it's in a more familiar programming language as opposed to learning SQL. High availability, NewSQL does that as well. I mean, we have high availability. If we have 20 servers, one goes down, we probably have the data on one of the other 19, we're good to go. And scalability, we can go from 10, if we want to add more capacity, we just add more servers. I don't know if I want to do this. I will get rid of this too. All right. Anyway, we talked about the flexible schema, familiarity. This is just some more detail on the same kind of things. Um, and then just the same thing, more detail on the things that I just mentioned. Um, okay, there we go. I don't want to go into that. Some disadvantages, less mature technology. I mean, SQL's been around since the 70s. A lot of these NoSQL databases are relatively new, so they're learning as we're learning. I've worked with some of these tools and I've found bugs where they're like, oh, we have to fix that. Sorry. So I mean, software takes time. And I never worry about broken software because if software didn't break, I wouldn't have a job. So I'm perfectly fine with things not working as long as I can explain it. And like I said, there's going to be less toys more than likely. I mean, SQL's been around forever. There's all kinds of tools and different things that you can use. Modeling complexity. That is true. It's very, I mean, think about it. We have normalization, we have data, ERD diagrams, we have all these things. Modeling NoSQL data is a little more complicated and it's a little more different in the way that you approach it. In some ways, I think it might be simpler in the sense that, like, let's say if I'm looking at a JSON, if each one's a separate JSON, then that's the model. Each one is a separate, disparate piece of data. This piece of data doesn't talk to this other piece of data. Depends. If you look at like how you model Cassandra, Cassandra is definitely more complex because you have to have a separate table for every piece of data that you would search upon. So, I mean, every column you would search upon makes it far more complex. So it just depends. Um, Less robust capabilities. Sometimes I wonder why I write this stuff. Um, eh, yeah, okay. Here's what I'll say about this one: the lack of joins. So I love it. So one of the things about engineers that I've never been this type of engineer because I've been fortunate enough to work with one of my jobs I had my own company. I was a preferred provider at one of the second largest bank in Chicago. I was attached at the hip to the president of all of trading. I learned very quickly what matters and what doesn't matter. A lot of times engineers do things because they want to, improve their resume or they think something's cool. And I've seen so many people say, "Hey, I'm going to use Mongo to do this, this, and this." And then I'm like, "Well, don't you realize that this piece of data needs to talk to this piece of data?" Oh, you probably should have used the relational database for that. If data needs to talk to other data, you either totally denormalize it and all of it, or use a relational database. One of the other concepts I want to talk about is the concept of metadata. Metadata is very important. Actually, one of the jobs I got, the guy hired me immediately because I discussed metadata with him. Metadata is, quite frankly, data about data. So, as an example, let's think of metadata within MySQL. So, the actual data, let's say, is we have a sales table and it has a salesperson and maybe they belong to a sales team and blah, blah, blah. Well, the metadata would be the table is called salesperson. The column is salesperson ID and salesperson last name, first name. So it's describing our tables, it's describing our columns. And we can use that data. This is what I do. I build code from metadata to rebuild things. I don't type. Typing is for people who don't understand how machines work. Typing is for people who like to type. I don't like to type. So I write code to build code to build code to build code. I'm different than most people. Anyway, well, maybe not. There's some other people who think like that, but I'm surprised how many people don't think like that. I mean, I was jokingly at some presentation. The machines work for me. We don't have Skynet yet. I don't work for them. They work for me. They are a tool to make my life easier. It is not my job to be doing manual stuff that a machine could be doing for me. Anyway, I'll get off my soapbox. Anyway, why do we combine data and metadata? Because, like I said, all of that information is helpful. The salesperson, Craig Bell, I'm a salesperson, but it also helps to know that my data is in the salesperson table. Linking that data together can provide additional information and help us better understand what we're doing. It can improve the quality, it can enhance the discoverability of data, and give us a better contextual understanding. That all sounds like stuff I would never say. I forgot where I got this from. But anyway, metadata is important, and the metadata is really important. There's actually in MySQL and most relational databases, there is something called an information underscore schema, and it is a very important schema because it tells you your metadata. As an example, information schema dot tables tells you everything you need to know about tables. Information schema dot columns tells you everything about your columns in your database. There's one for primary keys, foreign keys. It's just really good to understand that. So one of the things that I used to do is obviously it would be wonderful if everyone gave you a data model and you could just see what the data looks like. But unfortunately, we don't usually get that. So one of the things you can do is if you're trying to learn about what's in a database, you can query the metadata. I can query the metadata and say, hey, this database has 20 tables. Then I can start picking tables and say, okay, hopefully people use logical names. One of my jobs, there was a guy who was into Shakespeare and he named everything after Shakespeare characters. The database didn't make a bit of sense, but most people aren't that dumb. So most of us, if we have a table called salesperson, I can derive, okay, this is a table that has a list of our salespeople. If there's a table called products, I can imply that more than likely there's a list of our products. You know what I'm saying? But using metadata can allow you to be able to scan a database. I used to do that because I used to work as a consultant and I would go to different sites, or I had my own company. I worked for a software company as a consultant, and then I worked for different types of consulting companies. And it was really important to be able to know, okay, what's going on? Okay, I'll log into the database. No, people love documentation, but documentation, no one has time to do it. I miss the old days. When I was in the banking world, they said I was too important to do documentation. So I had two ladies whose entire job it was to follow me around and write down what I said. God, I was such a megalomaniac back then. But anyway, now I'm just a regular guy. But to make a long story short, you come in, they want to, the fastest way for you to get up to speed is to be able to look at the metadata and say, hey, here's all the tables. And then you start building your own documentation and everything to figure out what's going on and start looking at the relationships, especially if they make the columns the same names, or if you query the primary key and foreign key tables, you start seeing the relationships between the data too, if it's a relational database. But even your NoSQL databases have some form of metadata. The last thing I'm going to talk about is open source. And I love open source. And you know why? Because every piece of so one of the speeches I always give, yes, if you can't tell, I love to talk and I love giving speeches. But one of my favorite speeches that I always give to everyone is everything that I work on, everything that I do, software is free. So I always ask my students, why can't you be me? Why can't you be better than me? Why can't you be amazing? Why can't you learn all of this stuff? It's all free. You have a laptop, it's all free. Every piece of software that I work on, for the most part, I mean, yeah, Snowflake costs money, but you look at MySQL. None of you are paying for MySQL. If we chose to use Postgres, nobody's paying for that. If we wanted to use MongoDB, nobody's paying for that. Redis, any of the databases we use, nobody's paying for Java. Nobody's paying for Python. Nobody's paying for any of this stuff. So I always give it's me. I was raised by a World War II vet. He does not tolerate, my dad did not tolerate foolishness. My dad did not tolerate excuses. And I have a little bit of that in me. I'm not quite as rough as he is, but my point is that open source has opened up the world to all of us. All the software is free. You can do whatever you want to do. You're a business person, let's say, and let's say you have an interest in programming. Pluralsight, YouTube, LinkedIn Learning, download the software, put it on your laptop, learn it. Yes, you learn it, you'll do it. Yeah, I mean, that's why, like, when I interview people and stuff like that, that's one of the things we actually look for at Adobe. We're like, what are you doing at home? Because at least what, as an engineer, I can tell you right now, we put in, they have done studies. People who do what I do for a living, we put in more time studying outside of work than doctors do. Okay, this is a rough way to make a buck because the world keeps changing consistently. But the beauty is with open source software, I remember the old days when I used to have to like allocate several $1,000s out of my own pocket just to learn stuff because I had to buy it. Or when I used to do mainframe stuff, who's going to give you access to a multi-million dollar mainframe computer? You know what I'm saying? But nowadays, anybody can get access to anything because all the tools are free. So anyway, I'll get off my soapbox, but it's one of my things I'm passionate about. I always give students a hard time about it because they're all, especially like CS students, are always gamers. And I always ask them, I'm like, who's here not to get a job? No one ever answers. Are any of you good enough at gaming that somebody's going to look at one of these streaming sites and pay to watch you play? If you aren't that good, then you really should, I mean, play your games. Everyone's stressed out. Everybody has things they need to do. But if you play games 4 hours a day, maybe spend an hour and a half writing software. Maybe spend an hour and a half learning something new. Anyway, I'll get off my soapbox. Again, thank you very much for this. I love doing these videos. I hope they help you. I hope you're enjoying them. Um, like I said, reach out to myself or Professor Churi with any questions or concerns. We're about to do the fun stuff. I have created 4 databases, and each of them have a table with at least 1 million rows in it. We're going to start doing Power BI. You're going to load those databases into MySQL, and you're going to start being able to write some code, which is what I like doing. So anyway, hopefully you enjoy it as well. I mean, this class is still a work in progress. I'm still working my way around it. But like I said, hopefully you're enjoying it so far. And like I said, feel free to reach out with any questions or concerns. And again, thank you very much. I appreciate it.